Hello everyone, welcome to our BOTX tutorial on how to use deep learning and online assistant to predict how likely it is that you can suffer by some heart disease within the next 10 years. So, like for every machine learning or AI model, the key part of this tutorial will be about the data. We will use dataset from the kaggle.com website. The particular dataset is based on the Framingham study, which was basically a study conducted in the Framingham town in Massachusetts. The study has already began in 1948 and contains about 5,000 of cases. The cases looks like something like this. So basically our data is having these columns that you can see right now. We have data such as if the person is male or woman, the age of person, whether the person has higher education or not, if it is a smoker, and if it is a smoker, then how many cigarettes per day. We have information like BP meds, which stands for the blood pressure medications. So basically these columns tells us whether the person already takes any blood pressure medicaments. The prevalent stroke tells us whether the person had a stroke before. The prevalent hype stands for hypertension, and hypertension means the elevated blood pressure. So basically if you already have higher blood pressure, then this column for this particular case will say yes. Diabetes, whether the person has diabetes or not. We have a total col, which stands for the total cholesterol levels. The total cholesterol level is based on the formula, which is based on the so-called good cholesterol and bad cholesterol and triglycerides. So basically, this is the summation of it, and to show you maybe on the website how the calculation is based. So basically we don't have to go into much detail, but this is the formula which basically says which basically summates the levels of high density, low density, and these triglycerides. And we usually don't want these levels to be above 200. So if it's above 200, it's already considered elevated. Then the data consists of the systolic blood pressure, diastolic blood pressure. This is of course well known. We have body mass index, heart rate, and current glucose level in blood. The glucose level is basically a measurement of the sugars concentration per deciliter of blood. Usually doctors will ask for like fasting blood sugar levels to determine how likely it is that the person has diabetes or not. These fasting blood sugar levels, if they are above 120, it's already considered likely to be some indication for diabetes. And of course, the last column of this data, this is the important one that we want to predict. And this column is basically whether, based on this data, whether the person will develop likely within the next 10 years any cardiovascular disease or not. So this is just for the short description of our data. We have over 4,000 records, as you can see here. And we can go straight to the BOTX. So I will start from scratch to show you the whole process. BOTX of course, we will use our DCS platform, which is the data platform of BOTX. I have already a couple of systems here, and for this tutorial I will create completely new system, so you can basically go through the process yourself. And let's call this one, for example, tutorial. Let's say tutorials. Next, we want this to come up from empty data set, and language can stay like this. Perfect. We have our tutorial systems here. The next thing that we want to do, because this of course is a blank new system, it will be completely empty. So what we want to do is to define the system. So let's go to model setup. And currently the model has no tables. So we want to create the first table. Let's call it heart disease dataset, for example. And let's just go next. We don't have to change anything, and let's click finish to create the new data table. And here for this particular data table, we want to basically come up with definition of this data. So if you will look into your data, we have of course the CSV file, and usually you want to reflect on what data you hold. And I will just go, we have like male, age, college education or higher. So I will just put this aside, and I will go one by one and create these fields in the BOTX. So the first one was whether it was male or woman. So let's go, this will be a list, male. So we have created our definition. As you can see, this definition reflects our Excel file here. Just maybe a couple of tweaks we can do here, because some of the column names are maybe not so descriptive. So we have a display name option here to basically make it more like user friendly. So for example, for this sysBP, we can just type systolic blood pressure and diastolic blood pressure, to just make it more descriptive from the user experience point of view. The rest is pretty much okay. Maybe here we can just say hypertension. Let's say here it will be blood pressure, meds, and the rest I think is looks perfect. So let's just save this definition. Let's hit save button. And maybe now you can just go back and you can, let's see how it looks. So if we enter the system, we can already see that our table is here, the heart disease data set. And you can see all the columns here, which we defined in the step before. And now is the time when we can basically just import the data. Yeah, so we have our definition, and we just now want to import our training CSV file. So let's choose one. Open. Now, basically this dialog asks you for a mapping. So it will tell you which columns it detected in the CSV file, and your job is to tell it to which column it becomes in BOTX. So since this is just one-to-one, we can just hit the assign sequentially button and it will automatically fill all the fields itself. Let's just make a quick check. Yeah, sysbp, 10 years. And just to make sure that all the data is being imported, you want to check all these autofill options here. The autofill will basically try to scan all the data file or all the Excel file and come up with all the unique value in this Excel file. So it will basically fill the options for you in the BOTX. So we have over 4,000 items. Let's click import. It should be pretty quick. Yeah, it was. This is usually very fast. It's within seconds, even for a fairly large number of data, and we can basically see all the data here. Yep. 4,133 items. Perfect. So now we have our data in the BOTX. This is our DCS platform, so you can take advantage of all the feature which it already has. So you can, for example, if you would like to create new record, you can just hit the new button and it will automatically show this dialog for you. When we click here, you can see that this yes or no, it just detected it itself, and it would do so for any other list value. So let's cancel it, and let's now go to the AI area of BOTX because we have our data already imported. So now it's time to create the AI model. So we will do so by creating a new agent or a new robot. Let's call these, for example, heart disease predictor, for example. Let's click next. Let's choose cognitive diagram because our deep learning capabilities are basically within the cognitive diagram framework. So we want cognitive diagram type, and let's just click the finish button. Perfect. So the agent is created. I can click just right here to go to the agent detail. And here, basically, you see the details of this particular robot. It's completely empty now. And to define the robot, we have the hypergraph editor here. So basically here, we want to define our AI model. And let's start with the input data. Of course, each model, each AI agent or robot, everything starts with the input data. That's what this is all about, right? And the next thing we will need is the convert from JSON. I will say a little bit about it in a couple of moments. The next thing, of course, we want our deep learning. This is the heart of our agent. This will be basically the neural network that will do all the predictions on that data. And we want to import our database, which we just imported into DCS, and we want to spit it out. Whatever deep learning predicts, we want to basically convert it back to JSON, and we want to put it to output. Now it's just the question of connecting the nodes together. So input data goes to convert from JSON. The JSON is because basically everything in BOTX is based on API, the web API. So any third-party system, anybody basically, these days you can call API even from Excel. And everything basically here can be invoked by anything that can call API requests, which is pretty much everything these days. So the JSON we want to put into the input of neural network because this will be our input. The training data that we imported into DCS, we want to connect to training data of deep learning. And whatever prediction our network does, we want to output back to JSON, so it's consumable by any HTTP third party, and JSON just connecting back to the output data. This output data is the final destination of the information flow within this diagram. Now let's save the diagram and let's just make some options. So let's click the show node options panel here and select the input DCS. So as you can remember, I created our tutorials system for this particular tutorial. So let's select it. And I created heart disease dataset table. So let's select this table. Now in this table, we said that everything serves as the input for the robot. The only thing which we want to predict is the disease. So this is basically yes or no feature. And this we need to say that this is what we want to predict. This is the place where we say this. Or it could be anything else, basically. Anything that we want to predict from our data, we can define here. Now I will just disable cache to basically not have any artifacts during retraining, and just to make sure. And the next thing that we want to set up is the output data node. Here we just want to spit the output result of this particular port. Because the output basically can output anything. It can be email or it can be any text. And this output node, it's basically a template. So you can for example, if it would be consumed by some third-party system which expects text, we could say, let's say the result is, and the output with the $sign is the variable. So basically this serves as a template for any output. And there could be, of course, more variables if we would predict more data. But it will be just output. So let's save this. And let's save the whole diagram. And now the diagram is saved. Let's refresh the page, and you can see that everything is nicely saved. Now the most important thing here, of course, is the heart of this agent, and that's of course our neural network that we have not defined yet. So let's do this. Let's select our deep learning node and go to options. Under the options, you can see that we have just a button here to open deep learning editor. So let's just click the button, and this will open our deep learning editor. Now, for any neural network, if you are familiar or not, basically a neural network, it's inspired by the biological network, which of course we all know sits in our brain. And it's made, deep learning stands for deep because we can have multiple layers of neural networks, of basically neurons. Since this usually takes some experience to come up with particular numbers and layers and topology, we have auto-suggest params here. This is a unique feature of BOTX, and when you click the button, the BOTX will try to come up with the topology and number of neurons itself. So a very handful tool. You don't need to be machine learning expert to basically try to come up and try to determine some numbers here. BOTX will try to do it for yourself. And it also determined that we want classification. If you remember our data here, we want to predict whether there will be disease within the next 10 years or not. So this is yes or no, and this is for classification. This is problem for classification, basically. If it would be some number like, let's say 77.5 or it could be, for example, probability, right? Let's say 55% of probability. If it's continuous value, then here we would choose regression here. But since this is classification, let's just make sure that this will stay as the classification. Okay, so let's save this neural network and let's save the whole diagram. Now the agent is ready to be trained. So before you can train the agent, you must first switch it on. So let's switch on our robot on the details page here. And perfect, the robot is switched on and it is in the idle mode, which basically means that it's doing nothing. So let's go to Hypergraph editor, and from the training menu, let's choose deep learning. Deep learning is the only trainable node that we have here. That's why that's basically the only option here. So let's just click deep learning. And as you can see now, the robot is being trained on the data. So let's just open the training log. And this was very quick. We can see that the training is already done. So perfect. The number of records, 4,000, is not really big number. So this was quick. Of course, with greater number, the time required to train the network would go up, and but this is not the case. So basically, we are fine. Perfect. So now we have our robot. It should be trained, and now the final thing to test is, of course, to see how well the network is doing. So we have a couple of options how you can test basically the performance of robot. Of course, if this is being called by API, it would be integrated into some of your systems somewhere, and that's one option. We have our debug menu here, which basically allows you to input any input for this robot that will go to the input node here. But since this is quite the Excel, it would be quite not so user-friendly to type all these columns and parameters. The easiest thing to do is to just go back to our DCS platform. Let's go to our tutorials model definition. Let's go to our heart disease dataset table, and let's just create one more field here, and let's say that this new field is button type, and let's call it, for example, BTN, which stands for button predict, for example, and go to settings of this button here. Basically, button is what it says it is. It's a button. We can do any action that we need to do when the user presses the button. Here in the options panel, let's first come up with some high-level information. So, for example, button caption. We want, like, let's call this predict heart disease. This will be the label or title of the button. The rest of the options can stay as it is. You can play with it yourself if you want. But the important thing here is the sequence of actions. So basically here I can define what kind of actions should happen when we click the button. So we want to call cognitive diagram. We want our heart disease predictor to be called. And we want to call it with already serialized fields, which I can just define here. So male, age, higher education, smoker, all these fields basically that we said are inputs, we will click here as the input. Let's go, except of course disease. Yeah. Disease is not, this is our output, so this cannot be considered as the input of this data, and button is also not the input. So let's just leave it like this, And let's click the save button here and go back. And let's click save button here. And now when we will go back to our system through the enter system button here, we can basically see that when we will open any record here, we should see our button. Yeah, so basically you can see that our button is automatically rendered here. Now when we click the button, the basically neural network is being called, and it will try to predict the information that we just have here. So when I click it, I can see no change, but that's only because neural network obviously correctly just says the same what is already here, which is yes. When I remove the value and click the predict, you see, it will say yes, which basically means that our neural network is pretty successful, because it can already say what really happened based on this particular historical record. Let's open some another record. This is some random one, and again you see no change. When I clear this field and I will just click the predict, the neural network correctly says no, which is perfect. Now, if we would like to start from scratch, and let's say we have some new patient, for example, and we want to, we will ask him some information. For example, are you male? Yes or no? Or let's say this is a woman. Age, let's say 65, higher education, let's say yes, smoker, yes, cigarettes per day, let's say maybe this is a heavy smoker, so 40, let's go 40, blood pressure medicaments, maybe yes, stroke, no, hypertension, yes, diabetes, let's say yes, total cholesterol, let's go, for example, let's go to 250. If you remember, as I said at the beginning, values over 200 are considered, generally speaking, not so good. You want to keep this number below 200. Systolic blood pressure, this is the higher of the values. Let's go, for example, to 140. Diastolic blood pressure, this is the lower of the numbers. Let's go, for example, to 95. Body mass index, this is the ratio between your height and weight. When it's 25 or less, it's considered healthy. Above 25, it's considered not so healthy. It's basically between 25 and 30, it's called pre-obese levels, and then there are like 3 types of obese levels, which are values above 30. So let's go, for example, this will be 31. Heart rate, this is the heart rate, which between 60 and 100, it's considered normal. So let's go to some elevated level, for example, 105. Glucose level. This is, if you remember, the fasting blood sugar levels that we mentioned earlier. Anything below 120 is okay, but if it's above 120, it's generally considered as indication for diabetes. So let's choose 130, for example. And in this particular case, the values don't look really so well. So I would expect these to be definitely strong indication that the person will develop heart disease within the next 10 years. But let's ask the neural network. So let's click the predict heart disease button now. And it says yes. So you can see that basically these neural networks can be very powerful when it comes to learning from the existing historical data. And this will basically conclude this first part of this tutorial. In the second part of the tutorial, we will show how to create your own online assistant, which will consume this deep learning network. So we want to create a chatbot, basically, which will ask you a bunch of questions, questions that we already have here, that we imported into our heart disease data set. It will ask you the questions, and right from the chatbot, it will just call this neural network, and it will give you the answer. But this will be for the part 2. All the links and data that you might need for this tutorial will be included in the blog, so you can download the training files, the file from our BOTX blog. So that's it. If you have any questions, don't hesitate to send us email, and we are looking forward for the part 2. Okay, thank you. Bye.